Okay, welcome everybody. It's now 3:02, and so I will start introducing today's webinar. Welcome everybody to the second webinar organized by the Adjust project. And as you can see from the introduction slide, today's webinar is about global inequality consequences of climate policies when accounting for avoided climate impacts. Our speaker today is Johannes Emmerling from RFF-CMCC European Institute on Economics and the Environment of the Euro-Mediterranean Centro on Climate Change in Italy. And I'm the moderator. My name is Elena Verdolini. I work at the University of Brescia, and I'm also a senior scientist at CMCC like Johannes. I am also the proud coordinator of the Adjust project. I will steal a few minutes of your time today to just introduce briefly the project, and then I will give the floor to our speaker from today. So Adjust is a consortium. It's a project developed by a consortium, and the acronym stands for Advancing the Understanding of Challenges, Policy Options and Measures to Achieve a Just EU Energy Transition. It is funded by the European Union through the Horizon Europe framework program on research, and the broad aims of the project are to increase societal support for climate transition strategies, to quantify the distributional and competitiveness impacts of climate mitigation policies, as well as the transitional assistance measures which could be put in place, to then understand the gaps in the capacity and motivation of public bodies to implement a just transition and identify actions to overcome them, making the achievement of a just transition possible, and to promote inclusive procedural and transitional assistance measures supporting the achievement of a carbon neutral society in the European Union. Within the project, we carry out many activities, all of which you can learn on our website, the project website. This webinar is one of the activities we carry out. We organize periodically webinars on the topic, on research papers and topics relevant for the just transition. So just a brief explanation of how this session works. I think you're all very familiar with webinars, but just in case, your audio and video are deactivated by default if you are a participant. If you need to ask a question or to say something, you can do one of two things. The first one is to use the raise hand feature, which should be at the bottom of your screen. And when you do that, then the moderator, which is me, will give you the floor at the appropriate time. Or you can write your question, your comment or question in the Q&A section, which is also very close to the raise hand feature on Zoom. So I would propose that I now give the floor to the speaker, and that we keep questions for the end of the presentation, unless they are extremely important clarifying questions or people not understanding, in which case you can also raise your hand. But otherwise, I would suggest that we wait till the end of the presentation to collect the questions from the audience. And lastly, let me just note that this webinar will be recorded. It will be uploaded on the CMCC YouTube channel, where you can also, see it, but also sponsor it and send it around in case. And if you have any further questions, you can email the webinar at cmcc.it email. So having said this, which I think is all I needed to do to introduce today's topic and today's webinar, let me just give the floor to Johannes. Johannes, the floor is yours. As usual, we have tentative approximately 40 minutes for presentation and then some time for Q&A at the end, roughly. Thank you very much for presenting today. And you're muted, so you need to unmute.
I did. Thanks a lot. Thanks a lot, Anna, for the introduction and presentation of the project and webinar. And let me now share my screen. Okay. Yeah, thanks a lot, and welcome also from my side to this webinar, and the second webinar actually in the Adjust project, where I will be discussing topics around inequality, the impact of climate policies and climate impacts on some work that we have been developing over the last year within the Adjust project. So to start with a bit the project, let's say, or the main framing is that, well, just transition. There has been a manifesto written within the Adjust project is about, of course, how to manage, let's say, decarbonization, climate transition to net zero eventually from an equity or justice perspective. Here, what we will focus on is on a household's financial situation, or basically I will argue that, well, I will not look into many other dimensions of justice, but I will focus on the really tangible financial implications climate policies and climate impacts or potential redistribution have on households. And here the important role is on heterogeneity and on the difference between households, so high income inequality in particular, because of course that's deeply linked to what is just or how justice is defined. We look at climate policies and especially also on carbon revenues and the redistribution of these revenues, of how they can be used as one instrument to overcome issues of injustice or unjust transition, if you wish. And finally, include also climate impacts in a model-based assessment to have a joint assessment of climate change and climate change policies. Half of the talk more or less is based on this paper that we just published in December that you can find here, which is basically the global part of this assessment where we combine climate impacts and climate policies. But it's also a bit with other angles that I will touch upon. So let me start with just some recent evidence on more like social sciences or survey-based evidence on climate policies and on the cost of climate policies and issues around distribution. First, start with this paper that just came out a week or 2 weeks ago, where basically they run surveys in I think 125 countries asking, would you be willing to contribute 1% of your personal income to climate action, to fight climate change? And basically they found around 69% of the world population would be ready to give up 1% or more of their income for climate action. Now that's quite some good news in the sense that individually people are willing to say, I will accept to sacrifice paying some amount of my income or expenditures to help fight climate change, which is a positive result. There's another issue that maybe people might not be aware what others are doing, but let's focus on this I think positive result. Of course, 1% might not be sufficient at the global level. That depends a lot on costs and other factors, but that's already something. Yet, however, and this is another survey run by the OECD, if you ask people, and here they ask in around 20 countries, what is their support for policies? So do people support or are in favor of certain policies? For instance, here the last one, carbon tax with cash transfers, are kind of a classical policy where you have a carbon tax implemented. You find that, well, only roughly 1/3 of the population, at least in high income countries, and maybe up to 50% in more medium income countries, support carbon taxes. So carbon taxes, while people might be willing to pay something more, still carbon taxes are not widely accepted and don't have a lot of support, and therefore also not electoral support and political feasibility. Now, I think that survey is interesting, and they looked at also what drives these differences in individual responses in the survey to climate policy support. And here on the left, you find basically that it's some empirical econometric analysis, which factors in terms of beliefs of people determine whether they do or do not support the different policies. You can see here a carbon tax is the blue, a green is a green infrastructure program, or a ban on combustion engines in red. A lot of things that you might have heard about, views about climate change, beliefs in climate change, knowledge about climate change, beliefs about effectiveness, trust, and general perception. These are the first four, typically have a small but positive effect. So basically, if you believe in climate change, you might be willing to support policies more likely. So there's some effect. The big ones, and I think this is really important here, is the negative ones. And they're the two biggest ones by far here are the distributional impact of each climate policy. So the biggest one here, which has the biggest coefficient, which is negative, determining that they are really if you believe that your own household would lose due to climate change, and that really affects lose in the sense of monetary value, that you lose income or you have to pay much more for certain goods that you consume, that really makes you not supporting a climate policy. Secondly, if you believe that low income earners would lose, that's the second biggest effect. Also, then if you basically believe climate policies harm the poor, you're not supporting climate policy. So it's really a question of inequality of distribution on yourself, and then in the end, if you look at the whole population, especially on poorer household incomes, poorer households. So I think, yeah, there's this kind of evidence that indeed distributional implications really play a large role in shaping support for climate policies, and they also, of course, matter for how just climate policies can be. So here, that's why here in this talk, I will only focus on these kind of household financial implications. And I start by, well, let's start on what we mean by household financial situation. Basically, we take a standard kind of budget constraint. So it's this is a typical standard budget constraint, but basically on the left-hand side, what any household, any individual has as an income per month, basically you can have capital income with a certain interest rate R, which might be taxed. You have labor income, of course, which in many cases the largest income, which is has a given wage and depends how much labor you supply. And you have public transport transfers. So these are called T here. And this is basically the household income, and then you can pay any vector of consumption goods C, and you pay a price vector, which is denoted by P here. Possibly you also pay some taxes on those. So this is basically your financial situation. The difference is your saving potential, if you wish. Now in green, these are the variables that the public sector can address, right? This is basically the tax system and the transfer system that the government sets. In red, this is your decision variables. Basically, you decide how much labor you supply and how much consumption goods to consume and what type of consumption, given that it's a vector. And so this is basically your budget constraint. And how climate policies and climate change impacts those. It can impact any of these factors. I will not go into all of them because you could discuss about each one a long time. There has been studies on capital. Of course, let's say if you let's say own a house in Venice that might be destroyed, you might think climate change could affect your capital. Climate change or climate policies can affect interest rates. For instance, stranded assets. If your rent or savings or pension contributions are invested in, let's say, including fossil fuel companies, you might risk to have a lower interest rate on your capital. Labor is the biggest topic, and that's typically the only one that is focused on in just transition. Basically, we say, well, your labor might be affected in the sense that your job gets destroyed because basically your coal company has to shut down and you will lose the job, in which case you lose all your labor income. It could be also that the wage, of course, if let's say coal workers are not anymore as demanded as before, this will drive down their wages and you might be not as able as to get a higher wage than before. So you can have this impact on capital, on labor income. Transfers is of course, that's something we talk about when we talk about redistribution. The bigger impact is then on the right-hand side, and that's kind of the consumption expenditures. So it could be, of course, if you have a carbon tax or any climate policies, prices of certain goods and services go up, especially energy goods, gasoline, but also meat and other goods. In fact, very often this is kind of decomposed. So we have consumption expenditures. You have the so-called direct emission-related consumption. So that's really gasoline, heating fuels, and electricity. So really energy typically. So it's mostly energy, which is around 2/3 of the total emissions that households face. But you also have indirect emissions. So any good that you consume, of course, have energy and emissions embedded in them. If you buy a computer, all the production that has been done for that, the primary materials, etc., also cause emissions, and they would also increase if you were to have a carbon price. This is around 1/3 of consumption expenditures. Now we're going to look at this from an inequality perspective. So we want to look at different households and look at the different impacts on this budget or this household financial situation, if you wish. On the income side, on the left, so as said, the just transition often focuses on labor income, so that your job might be lost, or that your wage might go down. That's of course one important factor. And indeed, there's some studies that show that the income side, it might be even progressive. It's not so clear. It might be progressive for richer households. There's some studies, so it depends a lot on the sector. There's not so strong evidence. On the right-hand side, the consumption, there it's pretty clear that, well, this is basically regressive because poorer households have a higher expenditure share on transportation, for instance, on housing, electricity. Therefore, the impact will be regressive. On the income side, it's a bit less clear. But we can include actually, and different studies do differently both sides in the analysis. So what we do is we try to use a relatively simple approach to combine these very complex different aggregates, consumption, income into one measure, which is an elasticity, is an income elasticity of climate policies or climate damages. And I can invite you to this nice tool, which I think is very similar to what we're doing. It's called the Carbon Price Incidence Calculator. It has been developed by the Mercator Institute in Berlin, also within the Adjust project, or with some support, at least from the Adjust project, which shows you by income decile. So you have to here by 1 to 10. These are the 10 different deciles of the income distribution. Here I take the case for Italy. And you see an effect on total household financial situation, as I shown before, for these 10 income groups. And let's say in green, you have the one without compensation, basically. And this is a $100 carbon tax. So $100 carbon tax. What is the impact on different income groups? And you see that for the lowest decile, basically, you have a loss of around 10% of equivalent household expenditure. So you lose 10% of your income purchasing power, basically, and it gets lower for lower deciles. The richest 10%, it's only about 6%. So it's slightly going down, and poor households pay a higher relative burden. They also have a compensation scheme where basically you redistribute carbon revenues to households, in which case the picture flips and you have a positive or negative impact, meaning that you gain actually. And you will also see similar results in our modeling. This is just for the past. This is an empirical model calibrated to using to an input-output model. And we use similar approach to this, but in a forward-looking application to climate change scenarios until mid-century, let's say. The nice thing about this tool is that it both includes indirect and direct emissions. So that's important because sometimes you only look at transfer. A lot of studies actually use only at gasoline. They look at the acidity of gasoline consumption, whereas this paper also has direct and indirect emissions. So all the embedded emissions in all the goods and services you consume are considered. And also another important picture you also can see here very nicely is the so-called horizontal inequality. So that is inequality within a certain income band. For instance, here the lowest 10% of the lowest income, the poorest 10% of the population, and you see that the impact here still has this kind of 95% confidence bands, in the sense that there's still a wide range even within a low income. For instance, in one decile, that even households are very different, and therefore there's an uncertainty range. That households are heterogeneous even with the same income. You might be facing 20% drop, or even only 3%. Maybe if you live on the countryside, you travel a lot with the car, etc. This might be very hard. Living in a very inefficient building, you might be facing much higher costs of a climate policy. So what we do with this curve, so this is one, for instance, for Europe, where there has been this study that the GDP impact, for instance, of Fit for 55, based on an economic model, is around 2% for the whole Euro area by 2030. That's the study from the OECD. And we use this elasticity, which is kind of income elasticity, around 0.8 to 0.95. I will explain how that's estimated. And this then will give us this curve, which looks very similar to before. You have the lowest decile here, and the relative then policy cost becomes lower as you get richer. And this curve is basically kind of representing an income elasticity. And this is a meta study by Dudolfson et al., where they look into 60 studies or 93 estimates, which for each, and you have GDP per capita, so it varies also by the level of income and the different regions in color, and you have an elasticity between 0 and 2, and basically values between lower than 1, meaning that poorer households pay a higher share or suffer a higher cost, and value larger than 1 means that they suffer lower cost. And the average value of the study is around between 0.8 and 0.95. So that's, for instance, this point here. And with this point, then you can trace back the whole distribution of costs along the income distribution. Okay, so and this then with this kind of estimation of the elasticities for which we have values for many countries, we can basically use the distributional impact of climate policies in the model. The second building block, a bit more conceptual, and then we will go to the results later on. So bear with me, this is just the last equation, is the incidence of climate impacts. Now, similar to the cost of climate policies, which affect GDP, et cetera, there has been a lot of literature, of course, on the impacts of climate change, also on the economic impacts of climate change. Burke et al. Here, a couple of examples of recent years that really estimate the impact of climate change on the economy, coming up with a best guess estimate of around 8 to 10% of GDP loss by the end of the century. And this is, however, only at the macroeconomic level, right? So what we did in a similar, well, in a parallel paper, was to estimate this kind of impact functions at a more finer level, and in particular using different quantiles. So here we use different deciles, Q from 1 to 10, and we try to estimate historically how different deciles have experienced in the past different global warming or changes in temperatures and precipitation over time. So this is a parallel works, and this allows us then to use the deciles for not only for policy, but also for the climate impact implications. And just to show you the main result here, when we then do a forward-looking modeling of household deciles, here you see for each decile, again, 1 to 10, 1 are the poorest 10% of the population, the 10 are the richest. And here now, instead of having one value, as I said, it's around 10% of GDP. Now you have instead a distribution, and the points here are basically the 160 countries that we look at, so basically almost all countries in the world. And the average is then basically the average of each decile, how much climate change reduces income by 2100 in this case. And the interesting thing, I think, from here is that basically we find this is slightly upward sloping, meaning that the impacts are the highest for the poorest deciles, or the poorest 10% have a quite large uncertainty range, but also the highest absolute value in the negative terms of around 12% of their income. And so it's slightly upward sloping. And really interestingly is that the richest 10%, so these are the richest 10% in each country, show on average even a positive effect. I think that's really a striking result. So we basically estimate one regression for each decile rather than do it only for GDP. And what we find is that there's still a lot of countries in which is negative, but on average, and for a large set of countries, the richest 10% are actually, or have in the past, gained from global warming. And that means that climate impacts are also regressive, right? So poorer households will suffer more than richer households. Okay. Yeah, just to conclude. So basically we have, for the damage side, we have here, this is again a summarization, that climate change is not only unequally distributed between countries, this is widely known. Here we have the between country variation. We know that countries that are more poorer countries that are typically, like say in lower latitudes, will also suffer higher damages. But also when you look within country, only within countries, we find a slightly downward sloping line of impacts, meaning that poorer households pay a relatively higher cost of climate change damages compared to richer ones. So both dimensions between and within distribution matter for distribution. Okay, so what we did then, once we had this kind of two building blocks together, the climate costs and the climate impacts, is that we use this cost-benefit social cost or cost of carbon IEM, which is called RISE 50 Plus, that we develop here at CMCC, which basically has an almost country-level resolution. Well, 60 countries, but for the large countries, they're all individually covered. It comes from DICE, but it includes now a lot of different additional features. It has country-level temperatures, calibrated mitigation costs at the country level, and we have this decile data implemented, which is important, so to allow really to capture climate costs and climate damages at the decile level of households. We also have work on CDR. This is a paper that we also just finished recently on the role of negative emission technology, especially DAC, which is actually on the side of capital, if you remember the budget constraints, so that it might be that, well, the people owning DAC companies, think about Elon Musk, some people might really have huge windfall gains from their capital holdings, and that can also have an impact on distribution. But yeah, here we'll focus on the general mitigation costs. Okay, so in the model, first, we have a baseline trajectory of inequality. If you look at the past, let's say we take SSP2. SSP2 is kind of the middle of the road, where basically the trends are a continuation of historical dynamics. Inequality, and this is global inequality, right? So this is the global inequality between all citizens. So it's an aggregation of between and within country inequality. And it has been falling a lot for the last since 1980 to 2010 because mainly the increase in China, partly also large poverty, inequality reduction in China and also India. So it has been falling, but of course, this is only a trend. In other countries, it has been increasing. And what are the projections saying in a baseline without climate change or climate policies? In the SSP2, we see that this trend is expected to continue. And the important part is what about the difference between and within country inequality? Because here we focus on within country inequality. Between country inequality has been studied already quite a lot. And what we found in SSP2 is that between country inequality is really becoming smaller and smaller over time. Whereas within inequality is kind of almost constant, in some cases even decreasing. And in any case, it's going to be more and more important. And this is a trend that also, like for instance, the World Inequality project in Paris by Luca Chancel and Thomas Piketty found that within country equality is really becoming more and more important. Countries are converging because of course, globalization, factor prices are equalizing, but within countries, disparities are widening over time. So that means also that within country equality, relative to total inequality is getting larger or over time, making it even more important to understand the drivers and the impact on these factors. So then we implemented a set of scenarios, now moving to the difference between the reference scenario. So the reference scenario is the one you just saw, that we have in black. This is basically just inequality without any further climate implications. And then we have a scenario in red, which is what would happen with climate change, but without any climate policies. It's like a reference scenario with impacts now, where impacts will play a role. And then we say, now let's assume we have a well below 2 degree scenario. So it's kind of almost net zero, I think by 2070, for sure staying below 1.5 degrees of warming by the end of the century. And we compare the inequality outcome. Inequality outcome in here, we see the global Gini index on top, which is now around 0.6 or a bit below. And you see the different scenarios, first of all. So SSP 1 to 5 are different socioeconomic baseline scenarios. They vary a lot, right? SSP 1, almost you get to 0.3 by the end of the century. Whereas in SSP 4, you can even have increasing trend, where basically inequality is worsen over time, reaching even up to 1.7 by the end of the century. So quite a large range, and socioeconomic dimensions and determinants really play a huge role. But here we assume them as given, right? We are not thinking what will happen to inequality in terms of how will wage differences change, how will tax systems change. That's of course, these are big macroeconomic drivers that are, let's say, much less in control than the climate policies we're talking here about, but we can compare them for different policies. So in green, again, you have the well below 2-degree target, the Paris Agreement target, if you want. And on top, you see, well, on the Gini is a relatively persistent measure, right? You see an impact of maybe 3 to 4 points of the Gini, which goes from 0 to 1 or 0 to 100. And then on the bottom chart, you see just the impact to show the difference. And we see in the green scenario, for which you have then 3 different scenarios of redistribution, which I should mention. The first, which is the one in solid, which is just, you have the carbon policy, but you redistribute without affecting the distribution, right? The distribution is unchanged. It's like a neutral redistribution. Then you have one that's in dashed line, which is the EPC, the equal per capita dividend. So you pay a carbon dividend to all households, which is basically like roughly 400 to 800 euros per year per person. And the third one is a pro-poor one, where we basically give the money only to the poorest 2 deciles or 1 or 2 deciles based on optimization as a second control variable in the model. And we see, okay, with the solid line, so first, climate change increases inequality. So we see an impact on the Gini. It's always that the red line is higher. So compared to a reference without impacts always increase inequality. Slightly different, but going around 2 points on the Gini by the end of the century. And this effect, of course, is reduced if we implement the well below 2-degree target. In solid, you see already maybe roughly we end up at half of that impact. So just because of limiting warming to 1.5 degrees, we are able to especially shave off the last increase towards the second half of the century. But if we then on top use the carbon revenues, not to just, for instance, repay debt or something, but to redistribute it to households, we can even decrease inequality. So now we are below the 0 line, meaning that now actually in the Paris Agreement world, we have a lower inequality than in the reference scenario. And this effect is even much bigger if we do the pro-poor redistribution. And this is, I think, key. It's a short-term effect, as you can see, that because it becomes lower over time because carbon revenues get lower and lower as emissions get too close to 0. But in the short term, you can have a big improvement on inequality with climate policies. And this is precisely because of the carbon dividend, which for poorer households can mean a significant amount of money. Okay, so this is basically the macro level results. And then going back a bit to the figures I showed before, how this is represented here, we just look at all countries together. So each of the box plots is all the countries, 57 in this case, the climate policies. So we can split the four elements that we have. We have the abatement costs, which are slightly regressive. So as you can see, this is slightly upward sloping. The lowest decile has maybe 1% of to pay, the highest around 0.7. We have net transfers. So these are the transfers due to a carbon dividend. And of course, they are much higher for poorer households. They can reach up to 100, 150%. For instance, in India, where the income in the lowest decile is just a few $100s, and they are having this $300, $400 of carbon dividend can be a huge amount to improve, actually reduce poverty in this case. And then we have avoided impacts, and avoided impacts are higher for the poorest. So really, it's a pro-poor policy, climate policy in a sense, because also impacts are affecting the poorest decile more. And we get a final impact, which is the last line, which is basically just how the total incidence of the climate policy scenario is compared to a reference. And we see the poorest, the first 2 deciles or even 3 deciles are almost always better off with the climate policy compared to a reference without climate policy, because they all gain, especially due to the carbon dividend. In the pro-poor case, basically everyone else is kind of indifferent, pays a bit, but the lowest really the poorest 10 or 20% of each country really gain a lot. And this, of course, from a poverty reduction perspective, could be also very interesting. Then we look at so what are the macroeconomic implications of this policy. So we combine, we look at welfare and GDP and also transfers, and we do it by different regions and by the different deciles. Which we aggregate to the poorest 20%, the middle 60, and the top. The darker the color, the richer the decile. By 2030. We have basically a policy cost of around 0.5% of GDP, 0.4 to be precise. So that's the cost at the macroeconomic level. In the long run, by 2100, on the other side, you have a gain. So this is the GDP gain, just because, of course, now transfers are avoided. So there's a big GDP gain of around 3% of GDP compared to the reference case. You also look at welfare, which you see here in red, in which case, when you have some redistribution, be it equal per capita or the proper scheme, you can already by 2030 have a gain because of this inequality reduction. So you have a loss on GDP, but if you then redistribute to the poorer households, actually the welfare gain might be positive already by now. So you don't have to wait until the end of the century, by which actually it's even larger, because you reduce. You have a GDP gain and you have an inequality reduction. So you have two positive effects of climate policy. But in the short term, you can even achieve it when you redistribute the carbon revenues. And then going back to the previous survey question. So then why are carbon taxes not supported? What we do is then, okay, so assume. Also, there's a big, let's say, knowledge gap, in the sense that people might not anticipate what is going to be the cost of a climate policy, over a certain carbon tax, ETS2, or whatever instrument you talk about. So we compute here for each segment of the population. We try to see if they are better off under the climate policy or in the reference without climate policy, without redistribution. And we show the share of the global population. Again, colors indicate the regions, and the darker shows the richer deciles. In 2030, usually, I mean, climate change is framed as an intergenerational problem, right? That we have to pay now, but we're going to be better off in the future. But this is more and more, becoming less so, because we see already climate impacts, and also we need to implement the policy now. And we do a climate policy without redistribution or with neutral distribution. 100% of the world is worse off with a climate policy. Because, of course, if you just have to pay for the policy, there's no positive impacts yet. No one would be gaining. Everyone has to pay a bit more for all goods that are now carbon tax, etc. When you do the equal per capita redistribution, this changes pretty much dramatically, in the sense that now 58% of the population at the global level are better off because of this redistribution, meaning that they would be supportive, theoretically, if they were only to consider their household's financial situation, of a carbon tax. And you see these are the poor colors, so the low alpha colors, which are the poorest, the poorer shares of most countries. In the pro-poor case, this is only around 20%, and these are really the poorest, because you really only give it to a certain amount of population. So in terms of policy support, having an equal per capita dividend really seems to gain an almost 2%, two-thirds majority of the world, if they were considered on the economic conditions. And this, I think, is really a key message of this analysis, to show that really the carbon dividend is crucial to today make enough people supporting climate action. Okay, we also looked in the Adjust project at several countries, and because we have this basically for any country, here I just show some figures for 4 selected countries that we also looked a bit at in the Adjust project, exactly the same figure. And we found basically for most countries, it's similar, in the sense that between 50 and 60% would be better off under an equal per capita dividend. Only the case of Finland, where basically even in the long run, you have 80% are worse off with the climate policy, because Finland, as a very cold country, would actually benefit, according to these impact estimations from global warming, and only a minority of 40% would be better off by the dividend. So you see also some heterogeneity between countries, but roughly speaking, the picture is confirmed in most countries. Okay. So far, we assume that this is just a national issue. Each country collects a carbon tax and distributes it nationally to its citizens. So, and one one extension that we have been brought to was to think, what about the international transfer, the international transfer issue? Of course, you could assume, well, we should also internationally transfer money. And one way to do that would be to say, well, what if not the country collects the carbon dividend, the carbon tax, and distributes it, but we do it globally? Meaning we have the carbon price. So this is the carbon price we get from this scenario, which is, let's say, around $400 per or $300 by 2050, and of course keeps rising. Emissions are going down though, so that's what we mentioned, that carbon revenues are going down, and we distribute it globally. So we give a global uniform payment based on the global collected carbon tax revenues. This is the dividend that we get based on this emission and carbon tax profile. Starts around 300-400 euros and goes up to 800, and after which it will kind of go down again because emissions are going down. Eventually, of course, at net zero, theoretically, it would go down to zero. So we're talking about $400 to $800 per person per year for the next 30 years or so. So let's call this a global carbon dividend. And we do the same analysis. And now you have this third pillar here, which is the one where basically we have this uniform global dividend, in which case you get even higher to around 65% of the population that would be better off economically, according to this model, in a world where you have this carbon dividend compared to a no climate policy world. So really climate policy becomes individually, rationally, if you wish, already as of now, basically, if this redistribution is decided. Yeah, so maybe just one last thing for another 2 minutes before I'm finished. We also, of course, this is all based on one model, which is calibrated, etc. But of course, with models, you always have to issue, well, is this robust? How do other models would capture this? Also, the different channels, the one I mentioned, capital income, labor income. Some models would capture those drivers. We only looked at the consumption factor for now. So what we did in another related study was to compare different IEMs using exactly or a very similar modeling protocol. Here we use 8 models and show a similar impact. And so you see in the different colors, the different models that are listed here. We have CGE models, we have IEMs, we have cost-benefit models, and also a Keynesian macroeconometric model. And here you see in the 3 rows, basically the impact just on inequality, in here measured by the Gini index. And as before, we have the climate policy, where we see that in most cases, the climate policy leads to a small increase in Gini, similar to how we saw in the first figure. When you have this EPC, equal per capita redistribution, you see this huge potential reduction, especially in the short term, where in some cases up to 10%, 10 points, sorry, on the Gini, it can be reduced, but for sure on average by 2 points. So this huge drop in the Gini if you implement the redistribution, which in the medium term still 1 point less, but of course in the long run is evaporating as emissions go to zero. And then we have the final, the avoided impact. If we add them in the short, there's no big change. So we see it's basically the same because impacts in the short term are almost zero. Whereas in the long term, we see a reduction, a consistent reduction in almost all cases. So you have 10 countries here, I should mention. So it's 8 models and 10 countries. And in almost in all cases, we have a lower Gini, lower inequality when you include climate impacts and the climate policy and the redistribution due to climate impacts being lower. So in the short, even a bigger impact in the short due to the redistribution. In the long term, also inequality is lower, now mainly because of reduced climate impacts. It varies by region. In most regions, it's confirmed. Only in the Nordic ones, like Canada, we see the opposite effect, that inequality could increase with climate change, as also the similar effect has been found for GDP. But yeah, so that's, I think, the the main message I want to convey today. So climate policies are mostly likely regressive, especially on the consumption side, but also impact side, income side, even though there's a bit more ambiguity. Redistribution, so it's really key in terms of make policies socially acceptable. And therefore also the just transition, I think, discussion can really benefit from this discussion on distributional incidence of policies, as heterogeneity and inequality plays a large role. And while, yeah, the long run climate impacts, I think also important to take into account, but of course, just transition is about now, it's about the next 10 years in which they might not play a big role, and therefore redistribution is key to gather a sufficient majority to implement climate policies such as carbon pricing. And with that, I'm done, and I hopefully on time. And yeah, thanks a lot, and happy to answer any questions if there are any. Thanks.
Thank you, Johannes. Thank you very much for the presentation. A lot of food for thought, a lot of very detailed, I think, also technical aspects, which I'm sure, you know, have a say in or have an impact on the type of results that you get depending on the model, as you very well explained. So let me open up the floor for any questions. So I suggest that people either raise their hands if they can, or they write in the Q&A box. There was already a question quite some time ago in the Q&A, which I'm going to bring up now, on a specific figure that you showed in the early part of the presentation. So, I'm going to give the floor to Ines, if possible, to ask the question herself, if she would like, and if she's still online. If not, I can interpret the question.
Yeah, hi, hello. Thank you, Elena. Oh, it's possible. Can you hear me?
Yes, Ines, please
Yes.
go.
Johannes, this was the slide number 6, I think. There you showed the overall impact of climate policies. And there was this impact with and without compensation. Maybe you can get back to this slide. And I think there was a mixture of the headings. You see, with compensation, this is the lilac one. It would be negative, especially for low-income households. And with no compensation, it would be positive. There must be a...
No, so that's, yeah, I mean, it's true. Maybe, I mean, this is a screenshot from the website. And I mean, you see the website here, cpicglobal.net, which is really, really great. It didn't say what is measured here. So what is... what it measures here, this is a change in household expenditures, change in total household expenditures. So positive meaning that you have to spend more, right? You for the same for the same goods, whereas negative would be it's positive. So it's
it's not the Gini or something or the income loss. Okay, I see.
So you have low expenditures, exactly. So, but yeah, but it's typically that you have this kind of very huge impact on the lowest decile. So you see that these are much more curved than the one without concentration. But yeah, the definition is different from the ones that we use afterward.
Okay, thank you.
Thanks.
Okay, so I want to see if there's anybody else who has who has questions for Johannes. But I'll take the opportunity and ask perhaps a couple myself. So I'm going back, Johannes, to the slide that I presented at the beginning, which with the project objectives, the Adjust project objectives. And as you may remember, there were 4 objectives. One had to do with, the promotion of inclusive procedural and transitional assistance measures. One had to do with public bodies and ability to implement a just transition. And this, I think, don't match necessarily, don't fit necessarily very well your contribution here. There are the other 2 objectives, which are on quantifying the distributional and competitive impacts of climate change mitigation policies and assistance measures, which I think sits very well with what you've shown us today. Basically, this paper allows us to figure out what are the climate impacts, what are the policy impacts. You sum the 2 and you try to figure out whether there is a redistribution scheme that can make so many people better off with respect to a baseline. Now, there is another objective, which is of the project per se, which says increase societal support for climate transition strategies, right? And I think what you showed us here is that basically we have the information, we have the results that make it so that we could convince people that climate policy with redistribution, with assistant measures makes sense. Now the question is, and this is a little bit of a challenge for you, as the coordinator of a JUST, when I then have to, convince stakeholders and tell them what you have found here. A lot of the people following the presentation today are researchers or others. I mean, what is an effective way to make use of these results in a way that we can communicate to others? So, for instance, you showed here this tool, the distributional impacts. It's very nice, and I think it's super interesting for somebody like me. But if I have to go and talk to business people and whatever not, it becomes very hard to make the point, right? Because you need to explain. So if you have any suggestions, or if you have any ideas, or if you've done any work in turning this paper into something more digestible for a non-technical audience, what would you put what would you shed your light on? Basically, that's the probably the question that I would ask, that I would like to ask you. And then there is a second somewhat related question, which is the following. What emerges from the results, and I may have misunderstood, is that basically there are differences across countries, there is heterogeneity, there are specificities, but the solution is actually a solution which could be equal in all countries. It's the same, let's say, compensatory measures and policy measures, right? And this is somewhat a little bit at odds with the way in which people talk about the just transition at the European Union level or in other contexts, which is there are regional specificities, the policies need to be targeted. What you're showing us here is that the solution is relatively simple in its theory, okay, a little harder in its application. So do you have any comment on this tension that I sort of see emerging from, a theoretical result, a modeling result from academia and from theory with respect to how people perceive that the just transition needs to be designed on the ground? So this would be my two questions. And let me just, sorry, Johannes, let me just say, because I had the floor and I needed to give people time to think, there is also another live question. So I would suggest that you park my questions for a second, if possible. I give Victoire, if it's okay, the floor to ask the question, and then you answer all of them at once if you want, or park mine, whatever. To
Sure.
give. Okay, Victoire, please.
Yes, thank you. Can you hear me?
Yes, yes.
Okay, I wanted to ask you if this model takes into account the expected increase in inequalities that is based on the current economic trends.
Yeah, no, that's a very good and important question. So that was indeed one of the starting points that we spend most time is to exactly calibrate the past trends and also the different projections. And that's why we needed to cover, of course, have the trends and projections for especially within country inequality as a reference, right? And yes, this is what you see here. So these are basically the simple model runs where we take within country inequality projections from a paper that has been estimated econometrically, and we use it to model the within country inequality trend. And as you were saying, the trends is typically much more consistent in SSP2, right? Which like the IPCC AR6 has like 90% are focused on this SSP. Basically, almost constant within country inequality. So it's in the future, it's going to be dominated. So most inequality, countries are becoming more and more equal. We have super rich in all countries. We have poverty across the globe, but within country, it's more and more unequal. And this is, I think, an important. Of course, as you say, and as you also said, there are many worlds possible, right? It could be that it even increases over time, or it could very fast decrease if, for instance, we have an agreement on a wealth tax or on a higher income taxation, global agreement on capital taxation. So a lot of policy questions, but also dynamics on how is wage inequality evolving, are wages diverging? AI can play a huge role on wage skill differentials, etc. So a lot of unknowns in this, but we take it into account, and then we run these 5 very different worlds just to span a bit of range. But as you say, I fully agree that the baseline matters, and that's the result is we saw a big increase over the past years. And the World Inequality Report also confirms this, and this trend seems to be most likely to continue, and that's why it's becoming more important. So yeah, it is definitely considered in this analysis.
Thank you.
Excellent. And Johannes, let me also give the floor to John Gomez Mahecha. He also has a question. John, please. We cannot hear you. You have to unmute. Yes.
Hello, this is Cindy. I'm joining with
sorry,
John's
Cindy.
account
Hi.
too. It's okay. He's with me. I'm just wondering, Johannes, thank you so much for the presentation. It's really interesting. I assume that I can imagine that the models assume that when the redistribution is done by each country, it is efficiently done. That there are no differences between countries of how they actually do this redistribution, or like political limitations of some countries, for example, in the global south, to do this. So I'm wondering if if there is any research of how these like the way on the ground this redistribution would work, will affect the results, or how do you expect the results, I mean, the overall results of the research will change if you take this into account?
Yeah, no, this is a very, very important question. And also it links a bit to Elena's first question about the policymakers' view on that. Of course, this is an equal per capita redistribution, assuming that it's there's no issue about the collection, the identification, and payment of such dividend. Which is, of course, might be not realistic, especially in countries with large number of, let's say, informal sector or lacking registers of people. Actually, in Germany, there was a big discussion to introduce a carbon dividend last year. They wanted to make the payment happen just to be able to pay every citizen a certain amount of the carbon tax revenue, and they said it was not possible within 12 months to implement it, and this is Germany. So parenthesis closed. So it is indeed, there are a lot of institutional and also political challenges. We did one case, on a different paper for India, where we take into account the targeting issue, that sometimes it's like PMT targeting schemes, etc. There's an issue of a targeting error. And basically, we're in between the equal per capita and the kind of pro more directed scheme. Equal per capita should be in theory the easiest system, right? Once you have a registration or a tax or any kind of registration, it should be possible, but it's still a big issue. You're fully right, and implementation and also political institutional issues. It might be a good idea to take them into account for future works. That's actually a good idea. But yeah, this is for now. It's based on a stylized, simple protocol. But yeah, these are very, very important points and we could think about how to implement them in the future. Okay, Elena, on your two questions, they were a bit long. I don't know if you have the time. We are at the hour, but yeah, I agree. We are thinking about how to present it, of course, for final products of projects, etc., in the most comprehensive and accessible way. We are working on surveys where we will use actually some of this work to ask how people have ideas about their distribution, about the curve that I show, their income and expenditure side. So that's some ongoing work in Capital, and but we'll think about how to link this more with the policy maker also. And that's fully exactly as important as the institutional question. Okay.
Absolutely. Yes,
Thanks.
Absolutely agreed, Johannes. And also, I think that you don't have to solve all problems within one paper. So this is, of course, a contribution within a JUST. And there's then the challenge to also look at other aspects and other facets. So, for instance, this issue of institutional capacity is something we look at in Work Package 4, and this may tackle some of Cindy's concerns. For instance, of course, there are 1,000 questions you can ask, but we're doing also other things within the project. So please stay tuned for our next webinars and through our newsletter, and check out our website. But as Johannes said, we are on the hour. We're actually 1 minute past the hour. I thank you all for your participation, for the questions, and I thanks once again Johannes for presenting, and him and his co-authors for the really nice contribution to the literature. Thank you, everybody, and see you hopefully at the next webinar.
Thank you. Thanks, Elena. Bye. Have a nice day.
Bye-bye.